Welcome back to PHP Security Pitfalls. In this video we'll be talking about cross-site scripting. Cross-site scripting, or XSS, is a common vulnerability. It is said that 65% of websites are vulnerable to XSS, which is a very scary number. Now, XSS often consists of injecting a snippet of JavaScript into the output of a web application. And now that can lead to scary situations. Let's have a look at how that could work. Imagine we have a blog with a comment form. I'll just create a new folder called XSS here. And inside of that folder, we'll create a views folder to fake some quick and dirty separation of concerns. Now we'll just have an index.php file, like so. And inside of the view folder, we'll have a file called head and a file called tail. And let's also create a file called body. Now I'll just paste in a quick HTML5 snippet like so. Then we'll just cut out these last two lines and paste them into tail. And then inside of the body, we'll create our form. We'll just set a label, and that will be a label for comment. And it will say your comment. And then just a break tag and maybe a text area. The name of comment, an ID of comment. And I'll tell you what, why don't we just take this and wrap it inside of a paragraph tag like so. And then we'll have another paragraph tag containing an input with the type of submit and a value of leave a comment. And let's make sure we spell that correctly. Now inside of index.php, we'll just require our view files. So that would be viewshead.php. And let's just copy that twice. And we'd need body.php as well as tail.php. So let's save this all out. So there's a simple comment form. Let's view it in the browser. Yep, that looks good enough. Okay, now next we'll create a view file which will hold the comment that was actually posted. So that would be named comment. And we'll just do a conditional there and say that if we don't have an empty post variable with an index of comment, then we'll just take that variable and echo it to the screen like so. And maybe we should precede it with some kind of heading like H1 your comment. And then of course we should also remember to require that comment.php like so. Okay, let's try and post that form. Put in some gibberish, leave a comment, and there you go, there it is. Now a regular user would use the form just like we have before. Just put in some text and hit the submit button. But of course you could type in any text you want. I could do a heading for instance. And then if I leave a comment, then that would be displayed to the screen. Now what would happen if I pasted in some JavaScript? For instance, an alert statement saying, you have been hacked. Okay, you're probably getting where we're going here. Okay, so we'll set some script tags again, and then do alert. And maybe this time we'll pass in the document cookies, like so. And now if we click submit, we see all the current cookies neatly displayed. Now this is where it becomes scary. Because if I can alert this to the screen, then I can also send this to another site where a script intercepts this cookie ID and we can hijack this user session. So how would we do that? Okay, we'll first start with the script tags and then we'll just do alert again. Only this time we won't just alert document.cookie, but we'll prepend it with a string. And that will be http myevilsite.com, which doesn't exist. But okay, it's for demonstration purposes. And then let's just assume that we have a file there called stealsession.php and make sure we spell that correctly as well. And then we just do question mark and append it with document cookie. I'll just copy this and hit submit. And as you can see, we've now constructed a URL to an evil site that can intercept the value for this session ID. Now let's take that just a little step further. What if instead of alert, we would do document.write. Just copy that again for future use, hit submit, and there it is, our strings written into the actual document. Now if you can do document write and just pass in the URL, then you can also pass in an iframe tag with the source equal to that URL. And then we would just have to make sure that we neatly close out that tag. And now we'll just post that again. And as you can see, here is the evil iframe. And we are actually calling my evil site and passing in the session ID. There's just one thing, and that is I do not want the user to see this iframe. Well, that's quite simple. we'll just take this tag and set some properties. Height equals 0, width equals 0 as well. And then we'll just set a style property, border equals none, like so. An invisible iframe here, but we are in fact still calling that evil URL. Now people, this is XSS scripting. It's of course a very simple example and one that can easily be fought, but the point is, if you can inject this kind of JavaScript into a page, you can inject any kind of JavaScript into this page, including AJAX calls, set request headers, and a whole bunch of other malicious things. Now, fighting XSS is not really all that difficult, but fighting XSS successfully is, and that's because you have to take into consideration any context that you can receive data from, but also any context that you will use that posted content in. I'll just give you an example. Let's just go back to our form and change that just a little. Let's just add another input, shall we? And that will contain the name of the poster. So this would say your name, and the name would be name, as would the ID. And this would be an input with a type of text. Okay, now let's go to the comment view, and let's just copy this. Your name equals post name. And there we have the comment, which is a fairly dangerous field. So let's just cut this and make sure we wrap it into HTML special characters. And we'll make sure to pass an entity quotes. And the third parameter will take the character set, which is UTF-8. Now, filtering HTML prone data like this is a good defense against XSS. So let's just see if that works. I'll just refresh the page here and set my name to Joost and paste in our malicious comment. I'll hit submit, and there we have our name and our comment, which has been neatly escaped. It doesn't look so nice, but at least it's harmless. But now watch what happens if I paste in a comment like foo and I paste our evil script into my name. Now when I hit submit, I seem to be getting an empty name, but instead I'm calling my evil site again. Now this is what context is all about. Don't just assume, well, they'll probably try and inject HTML characters into this field, but assume they'll try and post it anywhere. In fact, a proper approach would be to just turn it the other way around. Let's go inside of index.php and make sure we validate before we do anything else. Input validation is always your first line of defense, so it should be in place. It must be in place. Now let's just borrow the validation class that we created before and copy it into our folder here. Just close that out again. Now I'll just open up index.php and just copy this bit here, and we'll just paste it in here for reference. Okay, now we are requiring validation, and we have two fields. One's called name, the other one's called comment. We'll set them both to required, and that's it. Now let's see if we have everything in place. Let's just try and post an empty form. Now here we are getting our errors, and there it says abort. Now while this is not a user-friendly way of throwing exceptions, it is basically what we would have to do. If the input data does not specifically match all of the criteria, then we should abort. Okay, now let's try and see if we can come up with a validation function that will only pass if the input adheres to a very limited set of characters. Well, first of all, we'll just clean up this mess here. I accidentally copied in a PHP end statement there. We'll call the validation rule text, so we'll just add that to these fields here. Now it won't be necessary to jump the post at the screen, so let's just rewrite this and just say that if the validation fails, so if it's false, then we'll just run the errors here. Okay, let's open up our validation file like so, and we'll just copy the email function and make sure we set it to text. Now, like before, it will take a value and it will take a field name. Now, we need to make sure to alter the error message just a little bit. So we'll just do the field name contains invalid characters like so, and we'll delete this validation rule because we don't need it. Okay, now how are we going to check for valid characters? Well, we'll create a whitelist, and that would be a string, and it will contain a regular expression. And then what we'll do is we'll set a variable called valid and make it equal to preg match. For the pattern, we'll use the whitelist regular expression, and for the subject, we'll use the value that was passed through this function. We'll just close it off with a semicolon. Okay, let's set up our regular expression. We need to take the entire string, so that's from the start until the end. And in that, we'll just do square brackets, and every character between those square brackets will have to match the input. And the characters between those square brackets will appear once or more. So, what valid characters can we include? Well, we want to have a very, very, very strict whitelist indeed. Okay, we'll just include letters, and then we'll include capital letters as well. Maybe numbers should be valid, a space, a comma, a dot, maybe a plus sign as well, and of course a line break. And then we'll do semicolon as well, although I always think that's a bit of a dodgy character, but okay. And then we'll do colon, exclamation mark, underscore, dash, and we make sure we prepend that dash with a backslash to escape it. And then last but not least, we'll add an asterisk. And maybe for our Russian viewers, we'll also include Cyrillic characters. Now, please do not just copy and paste this code. This is just an example of a possible irregular expression. You will want to be extra careful when constructing a string like this. It should allow just enough characters for the visitor to perform his task, but it should not include characters that can help a possible attack. And even including the percentage character, for instance, can get you into trouble because an attacker can use it to construct another character with. For instance, a %3c is a URL encoded smaller than character and thus potentially dangerous. Now, if you want a good head start on validation, have a look at some of these frameworks. Zen Framework, for instance, has a great validator class, and so do Symfony and Laravel. Just check out their source code and learn. So that's quite a regular expression we've got there. Now, if the value matches against the whitelist, then valid will be true. If not, it will be equal to false. And if it's false, we'll set an error and return, well, false. Okay, now let's see if that works. We'll just return to the browser and enter some expected inputs. We'll do something like Yoast and pass in some libsym text and then just hit the submit button. And as you can see, validation passed and our content is being echoed to the screen. Now let's enter some unexpected value. For name, we'll just use Yoast, and for the comment, we'll use the evil script we used before. Hit submit again, and there you have it. The comment contains invalid characters. Now this is validation, and validation is your first line of defense. It's very, very important. So with that in place, let's just go over to our second line of defense, which is escaping. So it's back to our comments file. As we talked about before, this method here is considered to currently be a good safeguard against XSS attacks. So let's just make sure we include it everywhere where we echo possibly unsafe data to the screen. Now, to make life easier for ourselves, let's just create a file called escape. So escape.php, and I'm not even going to bother with an escaping class. We'll just do a function here called escape. We'll make sure to pass in a string and close that out. And what we'll do inside is just return HTML special characters, and we'll pass in the string. Make sure we set the flag to underscore quotes and use UTF-8 as a character set. And then of course we need to close this out with a semicolon. Now let's make sure we use this function on all unsafe data, or possibly unsafe data. So that'll be escape, and we won't be needing this. Now there's one more post that we're going to the screen here, so let's just wrap that into escape as well, like so. And this is very important because you have to be aware of all the contexts where you are using possibly unsafe data. So you might be using that as, plain text, but maybe you will also do something like this. Set a div with a class, and then maybe pass a variable into that as well. So that could be post name. This is where you frequently see omissions. So this data is escaped, that data is escaped, and that data is left alone. Please make sure to not do that. Now, before we can actually use these escape functions, I must make sure to include that file inside of our index.php. Just copy this line and make sure we'll require escape.php as well. Also, you need to bear in mind which filters to use there. Now, this is for plain text, right? But we might be required to echo HTML text as well. Maybe from our CMS, where an admin user stored it. Now, even if an admin user did store it, it's still considered to be possibly unsafe data. So you'd have to escape that as well. However, you cannot use HTML special characters there because it would mess up your entire HTML. Well, then what can we use? Well, escaping HTML successfully is a very tricky matter. Luckily for us, there's packages. I'll just do a quick search for HTML purifier. There it is. And let's just see if we can bring that into our application. So I'll just copy this, open up our composer.json, and just add that line to the file, like so. And now I'll just open up the terminal and make sure I cd into my directory and run composer update like so. And as you can see, that's brought the library into our vendor directory. And now I do need to require autoload.php inside of here. So we'll just do require, and then like with hashing, we need to traverse up 2 folders, go into the vendor directory and require autoload.php like so. Now let's just make sure we're not getting any errors. I'll just reload this page here, and that looks good. So now we are ready to set up HTML Purifier. Let's just go over to htmlpurifier.org and see how that's done. We'll go over to the doc session and then just copy this code. Open up our escape file and create a new function called escape_html. Make sure we pass a string into that and then close the brackets like so. Paste in this code and let's just clean that up. First, what we'll do is set a config which is equal to HTML Purifier config, create default, which will get us the default configuration for HTML Purifier. Then we'll create a new instance of HTML Purifier and store it into a variable called Purifier. And then what we'll do is we'll just return purifier purify dirty HTML, and instead of dirty HTML, we'll just pass in this string here. Now that should do. Now let's just quickly create a proof of concept here. Let's just go over into index.php and set up an HTML string. And it will be equal to HTML, and then we'll have an h1 tag foo, and then we'll set a script tag and do alert, I don't know, foo. Alright, so that needs a little equal sign there. And then we'll just do echo escape HTML, and we'll just pass in the string like so. Now let's see what that brings us. I'll just reload the page here. And of course we get an undefined function because the escape page is only required here. So we'll just require that on top. Like so, reload it. And there is our cleaned up HTML, just like we expected. Let's just quickly inspect the source code. And as you can see, all the JavaScript has just been removed. Okay, and that's all for cross-site scripting. Code safely, and I'll see you in the next video.